Okay, good morning. As you see, there is one topic in chapter 2 that I didn't cover because it was a little bit more advanced than the other parts of chapter 2. So now you have enough experience. I go back there and then try to finish this part as well. Okay. So the title is the absolute value, and I would guess that this translation is differentiability. Okay, so we want to talk about that topic. I hope that we can cover this today. If not, we continue tomorrow. Okay, so first I want to talk about the concept of absolute value, which of course you are familiar with, hopefully. But let us put this on a firmer ground here. So what is the absolute value of a real number? So I would say that let x be any real number belonging to the set of real numbers. So this means that you can imagine that I have the x-axis here, and this is my origin. This x can be exactly at the origin, or it can be at the left side, on the left side, or on the right side. Okay, for example, let us assume that this is x. The distance between these two numbers, the distance between the origin and the point corresponding to that number, is called the absolute value of that number, and it is denoted by that symbol. And when I say the distance, it means that it cannot be a negative number, yes? For example, if I have y here, then this distance is again absolute value of y. So here you see that x is positive, absolute value is also positive. And then in this case, even though y is negative, but still absolute value is positive. And if your point is exactly at the origin, the distance between the origin and that point is 0. If the point is at the origin, it means that the point is 0. So it means the number is 0. So this means that absolute value of 0 means the distance from the point corresponding to 0 to the origin. But the point corresponding to 0 is exactly at the origin. So the distance between them is exactly 0. Okay, but so it means that if I ask you, based on this geometric picture, if I ask you what is absolute value of 2, the answer is what? Is the distance from the point corresponding to 2 on the x-axis to the origin. So it means that you go and find the point on the x-axis, which corresponds to 2, and then measure the distance from that point to the origin. The answer is 2. And if I ask you what is the absolute value of -2, what's the answer?
2.
Again, you go and find -2 on the x-axis, but still you measure the distance. It doesn't matter, you again get 2. And so that is a geometrical way of thinking about the absolute value, which is actually quite useful. But if you want to define mathematically, if I want to define the function f of x, whose rule is absolute value of x. Yes? So I can ask a lot of questions about this function. For example, I can ask, can you draw the graph of this function? Or is this function a continuous function? Or is this function differentiable at that point? Whatever in principle you could ask about a function, you can also ask about this very particular function. So we won't try to answer these questions one by one. But before doing that, we have to have a better definition. This is a geometrical way of defining things, but we want to be able to do it analytically. So this is the definition of the absolute value, okay? Which is of course motivated by this geometrical picture. So I would say that let x be a real number the absolute value of x is denoted by that symbol, and is defined as follows. And is defined by, so this is the definition I want you to understand. So if I ask you what is absolute value of x, you will tell me that it is x itself if what happens, if the x that you put here is positive or 0. Yes? So if the x that you put in is a non-negative number, so the output of the absolute value of x is x itself, yes? As you just told me without even knowing this rigorous definition, so the absolute value of 2 is 2. But what happens if x is negative? What is the output of this? Negative x. Yes? Because if I ask you what is the absolute value of -2, you cannot just simply remove the absolute value sign, because if you do that, you will get -2, which is not the correct answer. But you want to get the +2. So if you want to get +2 out of -2, it means that you have to multiply it by a minus sign. Of course, you never do it in practice. If I ask you to calculate absolute value of numbers, you can immediately answer that. Yes, but it is very important that this absolute value sign is very ubiquitous in mathematics, and it is an oppressed, I think, entity in mathematics, because whenever you use it, but whenever you want to do something with it, the first thing that you do is to get rid of it. Okay? Because as we will see, we will have problems working with the absolute value. For example, we do not have that nice formula for the derivative of the absolute value function. Okay? So, this is important to learn it in that way. If I want to get rid of the absolute value sign, I need to be certain about the sign of the expression inside. If I am certain that expression is non-negative, I just simply take this away and just simply write whatever is inside. But if I am certain about that inside it is negative, still I can remove these, but I have to multiply everything inside by a minus sign. So this is the idea that I usually try to ask. The first thing I want you to know is to understand this definition is exactly what we did here. Is there any problem here? Is this definition clear? So absolute value of x, you look inside. If x is non-negative, the answer to this symbol is x itself. But if you look inside and what is inside is negative, the answer to this symbol is not x itself, is negative of what is inside. Yes, is that clear? Okay. But if you don't know if the expression inside is negative or positive for sure, you are not allowed to remove these absolute value signs. Okay? For example, if I ask you, what is the absolute value of the square root of 2 minus the square root of 3? If I insist to remove the absolute value sign, what is the answer? Yes?
It's minus square root of 2 minus square root of 3.
No.
Or what is it? Square root of 3 minus square root of 2.
Yeah, that's correct. Yes? So, because the square root of 2 and the square root of 3 are two numbers. If I want to remove this absolute value sign, I have to ask myself, am I certain about positiveness or negativeness of this expression inside? The answer is yes, because even though I don't know the exact value of square root of 2, I don't know the exact value of square root of 3, but I know that this one is smaller than that one. Yes, square root of 2 is smaller than square root of 3, so this difference is positive or negative? This is definitely negative. Certainly negative. Can I remove this? The answer is yes. But because this is certainly negative, you can remove it, but the price that you have to pay is to multiply the whole thing by minus sign. And then what happens, this minus sign change this one to positive square root of 3, and then change this one to negative square root of 3. Negative square root of 2. For example, can you remove absolute value sign from this expression? Yes? Because even though I don't know what x is, it can be 0, it can be negative, it can be positive. But whatever x is, x squared is certainly non-negative. Yes? So do I need this absolute value sign? The answer is no. I can remove it because now I am certain about that this is non-negative, certainly. Yes, this is certainly non-negative, so I can safely remove the absolute value sign. And what the answer is? What is the answer? X squared itself. So there is no need to write absolute value of x squared. But if I ask you, can you remove this? No. Yeah, of course we can remove it, but not as simple as that. We have to say that what happens if I insist you to remove this. It is not as simple as this one. You need to discuss. You need to tell me that if x that you give to me is non-negative, then in that case I am certain that this expression is non-negative, so I remove the pair of absolute value signs. So under that condition I can remove it, but that's not the only scenario, because it might happen that x is less than 0. Then what happens? I am certain about that this is negative, so I remove this, but I have to multiply by. So if I insist so much, then you have to write so many things, yes? It is not as simple as before.
Could you write like plus minus?
No, this is not correct, because plus minus doesn't mean, so because I need to know when this is plus and when this is negative. If you just simply write plus or minus, that is not correct. Is that understandable? So you cannot write plus or minus. So I cannot write absolute value of x is plus or minus x. It is not that complete, yes.
So if it's uncertain, we just write it out.
Yeah, we can just keep it. But I mean that I want you to understand that's not a very deep concept. So if you want to remove that, you have to be certain about what is inside. If you are certain about what is the sign of the expression inside, you can remove it following this rule. If not, it is better not to remove it, because if you want to remove it, you have to write so many things. Yes, that's why actually a good idea to work with the absolute value sign itself. Okay, any questions? Yes or no? Okay. Okay, so before actually moving, so what do you think is the interpretation of this? If I give you two numbers, x and y, in the set of real numbers, and I ask you, what is the geometric interpretation of this? So what is the geometrical meaning of the absolute value of the difference of x and y? Yes?
It's the distance between x and y on line.
It is the distance between the points corresponding to numbers x and y. Yes? So it means that if I go on the real axis, yes, for example, if this is the origin, by the way, it doesn't matter if both of them are on the right, both of them on the left, or one to the right, one to the left. For example, let me take y here and x here. If I want to find this distance between these two, the distance between these two is absolute value of x minus y. That's also a good thing to remember geometrically. Is that clear? For example, if I want to draw a picture here for you, so let me take x to be 2. This is my x, for example, and this number is 2. And let me take y to be minus 3. Yes, this is minus 3. This is y, this is minus 3. If I ask you what is the distance between this point to that point, what is the distance? This is 5. And if you calculate absolute value of x minus y, what do you get? You get absolute value of x is 2 minus 3, and the answer is absolute value of 2 plus 3, which is 5, and the absolute value is 5. So you see that you get the distance between these two. Okay, let me ask you another tricky question. So what is the geometrical interpretation of this symbol now? Yes?
I'm guessing like on a line, then we have x say at 2 and y at 5. Then it's from the origin plus the x's distance to the y's distance. So it's like that entire distance.
Okay, so when you say entire distance, you mean entire length,
Yeah.
because distance should be between 2 points.
Yeah.
I want to interpret it as a distance, not a length. Yes?
I guess you could say that it like computes the how I guess how similar they are on either side, I guess, of the origin.
No, x plus y, it means that you can interpret it in that way. You can say that x plus y is another name. I can write every addition in terms of subtraction, yes? So one interpretation is that if you consider this in your head as capital Y, then it becomes x minus capital Y. So if I ask you what is the geometric interpretation of this, you will tell me this is the distance between the point corresponding to x and the point corresponding to capital Y. Yes? Because we just learned that. If I have the difference, the absolute value of the difference means the distance between the points corresponding to x and y. So that I have the same thing. I have x minus capital Y, so this is the distance between x and capital Y. But what capital Y is, capital Y itself is negative y. So I can interpret this as the distance between points corresponding to x and minus y. This is one interpretation. Another interpretation, you can write absolute value of x plus y. Instead of x plus y, I can write y plus x. There are no differences between them. And then instead of plus x, I write minus x. And then I give the rule of capital X to this, and then this becomes y minus capital X. Yes. And what is the meaning here? This is the distance between y and capital X, but capital X is minus x. So we can interpret it, or the distance between points corresponding to y and minus x, or x minus x and y. So you can interpret it in two ways. Okay, another question that I want you to think about. I give you two numbers x and y. I want you to know what is the difference between these two. Yes?
They're equal.
Yes, because why? For example, geometrical picture, it is clear that what is the interpretation of this? This is the distance between x and y. And this is the distance between y and x. So they are the same. So remember that they are actually the same. So another question, how do you evaluate this relation? Because these are some common mistakes I see students make sometimes. So do you think this is a valid equality for all possible choices? Can I rely on this as a formula? Yes, so if you say no, you need to motivate why, for example, by giving me an example, yes?
For example, because on the absolute value of x plus absolute value of y, that has the basis of the distance between x and the origin 0 and y and the origin 0. Meanwhile, the other one is the distance between x with x added to y, but that.
Okay, but if you say yes, you need to prove it. What you are talking about, if you want to say this is not correct, those kinds of arguments in your head should give rise to a counterexample. Yes? True or false?
I think that it's true.
Okay.
It's,
Now, if you say true, you have a harder time to. So you have to work harder to prove it.
yeah, I think the left-hand side is, I think it is equal to the right-hand side, because essentially it is just, the right-hand side is just the absolute value of x, and well, x in that case might be positive. And
Okay, but that's not a proof. Yes. Proof means that 100% you should tell me this is why this is correct.
yeah, but what I mean is the right-hand side, both of those values are going to be. I don't know.
Yes, boy.
If
False or true?
if false,
False.
both x and y happens to be negative, then the absolute value of x would be, let's say x is.
This is not a
minus-
counterexample. You need to give me a concrete example, numerical example.
Yes, let's say.
So, for example, you say that this is false since, for example, this is the way that you need to write. You say this is false since, for example, now I want to wait for you. For example, if what?
If x is minus 3
X is minus 3 and
and y is minus 2.
okay, so you picked the wrong example, but let us check. Okay, x is equal to minus 3 and x is equal to minus 2. Okay, let us check. This is not a counterexample, because this is one of those cases that this turns out to be right. Yes, because the left-hand side is what? The left-hand side is absolute value of x plus y. But Buell told me that x is minus 3, so I take this away and put minus 3, and then I have plus. Instead of y, I put minus 2, as she said, and calculate this. If I ask you what is the absolute value of this number, you add them first, becomes minus 5, so this becomes absolute value of minus 5. But what is absolute value of minus 5? It is 5. And then the right-hand side is absolute value of x plus absolute value of y. But then absolute value x is minus 3 and then plus y is minus 2. So again, that's actually a good example. That's the reason that I'm just talking about. This absolute value of minus 3 is how much? Is 3 plus absolute value of minus 2 is 2, and the answer is 5. And then you see that the left-hand side is equal to the right-hand side. So I want you to understand, from a deeper perspective, if you come up with this idea, you are in a limbo situation, yes? You haven't refuted the problem, you haven't proven the problem. Because you cannot prove a problem by just showing that this works for this example. And you haven't disproved it because it is correct. So it means that we did nothing actually, unless we motivated us. Okay, might be that this is not, by the way, bad. I'm not disdaining this thing. This is the way that mathematicians actually do, because they don't know what is going to happen. They have to explore. Okay, can you fix your example now? So I want you to see that this is an example in the confirmation that this is working, but your intuition was right. This is not a formula that I can rely on it 100%. Can you fix your example?
Then let's put y2 plus 2 to
Plus 2. And then you will see that this will not work. Okay? So this is false since, for example, if y is equal to minus 2, x is equal to minus 3 and y is equal to positive 2. And then let us recalculate everything. Okay? Then the left-hand side is x plus y. Instead of x, I put minus 3, but instead of y, I put what? I put plus 2. Yes? Instead of y, I put 2. And then when I add them, what's the answer? It's not negative 5, it's negative 1. And the absolute value of negative 1 is 1. But now let us go to the right-hand side. Absolute value of x, absolute value of 3. Instead of x, I still put this one. But instead of that one, I put what? 2. And then still the calculation is the same. But then you see that the left-hand side turns out to be 1. And the right-hand side turns out to be 5. So this means that the left-hand side and the right-hand side are not equal. So this is important. So now hopefully, Melker, you understand that you cannot force the argument. So you have to have a very concrete argument that this is working. And then, so those arguments are not correct because this example shows this forever that you cannot rely on that. You can ask, of course, under which circumstances this works. And then you have the intuition. If someone tells you that, when do you think this is correct? Because you saw that in the previous example, sometimes it works. Okay? Okay, so it's a harder question now. I'm asking you under which condition or conditions this holds. Yes?
It works when both x and y are either both negative or both positive.
Positive. Yes, so in other words, if you want this works, if and only if x times y is non-negative. Yes? But these are not the things that I just want to discuss about these things because I want to improve your understanding about the concept. But this is not something you really need to know. But we discovered that more or less. But we didn't prove that, of course. That was a pure guess that this is going to work and this. But can you say, what can I write in, because what can I write in general? How do you think these are related? Is there any relation that I can say between these two always? Equality was not the correct relation because it didn't hold, at least for this example. Okay. Yeah?
I think that the case where absolute value of x plus absolute value of y is always greater.
Greater or on this circumstances equal. So that is a famous, this is called the triangle inequality. Okay, so yes, this is the general formula, but you can consider all these things here optional. It was just for a deeper understanding of what is going on. Let me give you an example. For example, these kinds of examples, I want you to understand it very good. So, example, let x be a real number such that 1 is less than x is less than 2. X is somewhere between, minus 1 and 2. Write the expression. So let us say A, capital A, to be equal to this expression. 2 absolute value of x plus 2. And then I have minus 4 absolute value of x minus 3. Yes, and minus 5 minus absolute value of 5 minus 2x without using the absolute value sign. Okay, so we want to do that. This is a good question. I want you to understand this question, solving this. So you see, first of all, absolute value is not necessarily working like a pair of brackets. This is also another common mistake. So if students just multiply 2 in, I want you to understand, sometimes it works, sometimes it doesn't. If you really know what is going on, you can do those things. But if you really don't know, don't do that, okay? For example, if it was 2 times x plus 2, I could multiply it as 2x plus 4. Here in this case, I can also do that. Yes? This is possible. I will talk a little bit about these things later, but if I multiply minus 4 by x minus 3, so what is happening? So this is minus 4x plus 12. Okay, I don't want you to multiply minus 4 in. Yes, in the absolute value sign, because sometimes if the number is negative, then you have a little bit of problems. Okay, but that's not the concern. The concern is that I have given you a condition on the number. Of course, how many choices I have? How many choices I have for this x, if x is a real number? Infinitely many. Yes, there are infinitely many numbers between minus 1 and 2. But for those infinitely many numbers that are between minus 1 and 2, I want to get rid of all absolute value signs of this expression if possible. So how can I do that? There's only one rule about it, yes? If you want to get rid of this absolute value sign, you cannot do that unless you are certain about if this is positive or negative. And that is why that condition is given. So now tell me, if you have x somewhere between minus 1 and 2, what do you think about x plus 2? Is it definitely positive or is it definitely negative? If it is something sometimes positive, sometimes negative, be careful. You are not allowed to get rid of these absolute values. Yes?
It will be definitely positive since x cannot be.
Yeah, x is somewhere. If you want to understand it better, let me just draw a picture for you here. So minus 1. So by the way, this is also good to know. Here is 0. Minus 1 is here. It is not including minus 1. So this is the way that we represent it in mathematics. So we put a hollow circle here. So this means that we go up to minus 1, but minus 1 is not included. That is also good. If you don't mind, let me change this problem a little bit so that you can also understand that one. If I put equality here, so this means that this is 1, this is 2. In order to show that I respected this inclusion, I would put a field dot here. So this means that the numbers are starting from minus 1, but minus 1 is excluded, and I can continue until 2, but 2 is included. This is the diagram, this is the way that we represent it on pictures. Okay, so now I know that x is somewhere here, but this x is 2 is added to my x. Do you agree that if I add 2 to any x here, and by the way, this is called an interval. If I add 2 to any x on this interval, what happens? This becomes definitely positive. So do I really need the first absolute value sign? No, because x plus 2, so I know that because x is between minus 1 and 2, we have x plus 2 is positive. So this means that absolute value of x plus 2 is equal to what? Is equal to x plus 2 itself. Yes? This we know. What can I say about x minus 3? X is at most 2. I am taking 3 from it. So what I am left with it? Yeah, just say it, yeah. Certainly negative. So this means that x minus 3 is certainly negative. Okay? So this means that absolute value of x minus 3, can I remove absolute value sign?
Yes.
Yes, but I have a price to pay because this is certainly negative, and the price is to multiply everything inside, total everything inside by minus sign, which becomes 3 minus x. But what do you think about 5 minus 2x if x is somewhere between minus 1 and 2?
It's positive.
It's definitely positive, yes? Do you agree? This is positive. So 5 minus 2x is definitely positive. Yes? Why is that? Because if x is positive, when you multiply, because it is at most 2. When you multiply it by 2, it becomes at most 4. So it cannot actually overcome to this positive number. It remains positive. If you are on the negative side, the situation is even better. Because if x is negative, you multiply it by negative, it becomes positive, and then you add it to 5, again becomes positive. So this means that on any circumstances, when you are in this interval, 5 minus 2x is positive. So this means that, do I need the absolute value sign? The answer is no. The answer is exactly equal to itself. Okay? So therefore, what can I write for A? A is equal to, instead of these expressions, I put these. Yes? So I would write 2. Instead of absolute value of this expression, I put x plus 2 itself, but I hope that you agree with me, this is the wrong way of writing. So this means the absolute value turns into a pair of brackets. And then I have minus 4. Instead of absolute value of x minus 3, I put 3 minus x. So this becomes 3 minus x. And then I have negative sign. And then instead of absolute value of 5 minus x, I write 5 minus 2x, I write this expression. So this is the way I was able to get rid of all absolute value signs, and if I want, I can just simplify that. So I multiply 2 inside, and then I multiply minus 4 inside, and then finally I multiply the minus sign inside. And let's try to simplify that. So what's the answer? 2x and 2x is 4. Oh, sorry. 4x and 4x is also 8x. And then I have minus 17 plus 4 is minus 30. So this means that this expression only under this condition is equivalent to saying 5x minus 13. So we should be able to simplify things like that. Is that clear? Okay. Now, for example, let me ask you this question. We can solve equations involving absolute value signs. For example, solve the following equations. So, number 1, for example, let me write simple one. So the absolute value of 2x minus 3 is equal to minus 5. So what is the, I give you this equation, I ask you to solve it. What's the answer? There are no solutions. Yeah? Because it is not possible for the output of absolute value sign becomes negative. Absolute value is the distance, yes? So if I give you this accidentally, you would say that there are no solutions, yes? By the way, the blue lines are actually the correct answer to this problem. There are no solutions. Yes? Because the output. But let me make it positive 5 now. So what happens if I have positive 5? Absolute value of 2x. Let me make it 0 first. If I ask you solve this equation, what do I mean? I mean find all possible x's for which if you calculate this left hand side it becomes 0. So how should I solve that problem? absolute value of a number is 0. When this happens, if and only if and only if the expression inside is 0, because the output of absolute value is 0 only under one condition. So if I ask you, give me a number in this box so that its absolute value is 0, what can you say about the question mark? There's only one number whose absolute value is 0, and that is 0. So when you say the absolute value of this one is 0, the conclusion is that this happens if and only if 2x minus 3 is equal to 0. And then, of course, this is a very simple task, so 2x is equal to 3, and the x that you are looking for is 1.5. Yes? But now let me ask you another question, number 3. I give you 5 this time. Absolute value of 2x minus 3 is equal to 5. So how can I solve this equation? If I ask you, give me the question mark, give me a number whose absolute value is 5. Yes?
It can be minus 5 or 5.
5. Because I am asking about, can you give me all possible numbers for the question mark for which when I take the absolute value, the answer becomes 5. And you know that there are two numbers, one on the right-hand side of the origin with the distance 5, and one on the left-hand side of the origin with the distance 5 to the origin. So this means that you have to know that if you want to solve that one, and that is sometimes the mistake, people say that the absolute value is plus or minus. But this is, the interpretations are a little bit different. So we say this is 5 or minus 5. And then I have to solve both of them. So I move this to the other side, it becomes 8. So one answer is 4. And then I continue this. 2x is negative 2, x becomes negative 1. So be careful, these numbers are not necessarily opposite. Okay, but it means that if I replace x with 4, it becomes 2 times 4 minus 3, which is 5. Absolute value is 5 is 5, correct? If I put minus 1 here, 2 times minus 1 is minus 2, minus 3 is minus 5, but the absolute value of minus 5 is again 5. So this means that these numbers are correct. Okay, let me make it a little bit more interesting. Pardon?
When solving that kind of equation, would we have to check for like false
No,
numbers?
that's not, because that's equivalent. Because if you say that this expression in mathematics, of course, if a is positive, this is mathematically equivalent to x equals to a or x equals to minus a. Because these two expressions are equivalent, so there is no danger of falsehood.
Okay, and we can't get like negative, or that x is equal to some negative value. Oh wait, that's so far.
No, that's no problem. I got a negative value for x.
No, I mean negative value for x. Will you expect the expression to be positive, or were you like?
No. There is no danger because I know that they are equivalent. Okay, so now let me give this a little bit a twist so that we can think a little bit. So what do you think the solution to this will be? So number 4, we want to talk about, for example, an equation like this. I put an absolute value here, then I put another absolute value in, x minus 1, and then I write minus 3, and then I would say 5. So we want to find all possible values for x that satisfy this equation. Okay? So how should we do that? Yes?
Again, we have to think inside the absolute
So
sign.
this, you give the role of the box to this expression.
Yes, and that would be
So you do not look inside, yes? So if you do not look inside, that is the same scenario. I have absolute value of some question mark, which is supposed to be 5. So this means that what is the conclusion out of it? It means that what is inside the box, which is of course what? This expression, has two options, yes? What? One of them is that this one itself is 5, and the other option is that this number itself is what? Minus 5. Yes? And then I have to solve each one of them individually. Yes?
But the second one doesn't have a solution.
Yeah, we have to write it down. Okay? So, and then what happens for this one, what can I do? Do you remember the strategy is to try to isolate x? So let us move this to the other side. But of course, I cannot take this away. It becomes what? 8. I move 3 to the other side. Again, you repeat the process. Absolute value of something is supposed to be 8. Again, there are two possibilities, yes? So this means that x minus 1 is 8, or x minus 1 is minus 8. But x minus 1 is 8 means x is 9. That is one solution. And x minus 1 is minus 8. What does it mean? It means x is minus 7. That is another solution. But this was this one. I have to go there. Again, the same strategy. So I move minus 3 to the other side. It becomes minus 2. And then what should I say?
It's undefined.
Okay, don't say undefined.
There are no solutions.
There are no solutions. Yes, because I'm asking what are the solutions. You shouldn't say undefined. Grammatically, it's wrong. Yes, you shouldn't say there are no answers. Yes. So x minus 1 is minus 2. There are no solutions. Yes? So that is something that you need to understand. Yes.
So if there were some solutions for the second case, would that mean there are 4 possible fixes?
Yes. I can give you an example now that I wait for you to solve because I want to make sure that you understand this before moving on. Okay. This is also important. Okay, so let me give you an example and wait for you a little bit. So number 5, let me write it like this. I put absolute value here. I put 2, and then absolute value of 2, x minus 3, and then I would write so let me see, minus 7, and then I write 3. Okay, so I want to wait for you to solve this one, okay? Okay, did you solve that? So what are your answers?
I got 4 solutions.
Mm-hmm.
1 x minus 2, x is equal to 8, and x is equal to minus 1/2, and x is equal to 7 divided.
I don't know about the numbers, but my guess is that this time there should be 4. So let us check. So how we solve the problem? We tell to ourselves that you should be able. This is a very important skill you have to learn, and in mathematics courses are really essential for learning this skill. So you need to break down the problem, a harder problem, into simpler one. So you shouldn't be distracted by the complexity here. So whatever this is at the end is a black box for us. But we know the absolute value of the black box is 3, so there are only 2 options available for my black box, either 3 or minus 3, yes? So I break the problem into simpler one. So I would say that, of course, this is a harder problem, but it breaks down to 2 simpler problems. And usually solving simpler problems are easier for us to do, yes? So I just write them. So first tell me, do you understand the conclusion is right? So this expression is equivalent mathematically to either this one or that. Yes? But again, the strategy is try to isolate x as much as we can. So I move 3 to the other side. Let us do some of these in our head. Let me just write that. So this becomes 2 absolute value of 2x minus 3 I move this 7 to the other side, it becomes 10. So what's the next step after this? What's the next step?
We can move to the
We can divide, yes? You
right.
divide by 2 to get rid of this extra 2 here. So I divide everything by 2, so this becomes 5. And then what is coming next? Again, the same story. I have something inside, absolute value of that is 5, so there are again 2 cases. One case is that 2x minus 3 is 5. The other case is 2x minus 3 is negative 5, or. Okay, and then I continue this one. So this 2x becomes 8, x becomes 4 finally. So I got one answer here. And then I do the same thing here. I move this to the other side, 2x becomes negative 2. I divide by 2, it becomes negative 1. So this is what I got on this one. I will go there. So the same strategy. I move 7 to the other side. It becomes what? Plus 7 minus 3, 4. I divide by 2. It becomes 2. And then again I have 2 options, yes? Either 2x minus 3 is 2, or 2x minus 3 is negative 2. And then I continue this one, so 2x becomes 5, x becomes 5 over 2. That's another answer. And then I move this to the other side, so 2x becomes 1, and x becomes 1/2. These are my numbers. Yes?
Are you allowed to multiply 2 inside the...
Yes, let me just tell you, if even though this is not correct, do you remember we talked about this? This is in general not correct, but it is correct to write this for multiplication. And it is correct to write it for division. These are both true. Of course, in this case, y is not allowed to be 0. Okay, and then the question that you ask, I would say, if I have 2 times absolute value of x, your question is that, am I allowed to multiply 2 in? The answer is yes. Why? Because 2 and absolute value of 2 are the same. And then I have this one. So if I write this, you shouldn't complain because there is no difference between 2 and absolute value 2. And because this formula is correct, if I have 2 absolute values multiplied, I can multiply them and put 1 absolute value sign. So this means that because I have 2 absolute values multiplied, I can put this and write this.
so if it's minus 2,
Then it's a minus 2, you have to be careful. If it is minus 2 and you mistakenly, of course it is not wrong, because even if you do that, what happens? It becomes minus 2x. But absolute value of minus 2x and the absolute value of 2x are the same. Yes, because the absolute value of the negative of a number and that number are the same. But let me check. If I want to do it like this, but be careful. By the way, this is wrong now. Yes? So that's what I'm saying, that this is important to know what you are doing. If you write this, that is wrong. Why? First of all, do you agree with me this is positive? And if I ask you what is this is positive, but the whole thing is negative. So the negative number cannot be equal to a positive number. But if you want to do it properly, so that's why I'm saying, if you have a positive number according to this theorem, you can multiply 2 because I followed the theorem. But if you want to do this with negative numbers, that's what I'm saying, that I don't want to confuse you. So if you want to do that, instead of minus 2, I cannot write absolute value of 2. Yes? What can I write then? I can write minus this. Yes? And then I can multiply this in according to the rule, but there is a minus sign left. So this means that if you insist to do this, you need to keep the minus sign outside and then multiply the number inside. So if that's positive, it is always correct. But if you have a negative number and you still insist to do that, you can do it, but you need to remember to keep the minus sign outside and just multiply the positive number inside. So that's why, because the book is not going deep into it, and that's not part of your lesson, so I do not want to talk about these theorems in depth. Okay, is that clear? Understandable? Okay, now that we have a little bit good understanding about the absolute value, let us go and talk about the function whose rule is the absolute value. Yes?
So is there some, because I mean, the more absolute value signs you would add to an equation like this, I mean, it's exponentially going to give you more x's. So
If you are lucky that the numbers are not turning to be negative at the end, because it actually in the previous example, because of this negative sign, it actually stopped there.
It feels like it would take, like, let's say you have 5 signs, then it would be like 2 to the power of 5.
Yes, because now I will answer this question. I will try to draw the graph of that one using GeoGebra. You see that I have a lot of broken lines attached together one by one. So it is like an oscillating, it's like a sine function, but sine function is very smooth, but these are sharp lines. Yes, that's the difference. That's the other topic. So we will cover it probably tomorrow. I will not be able to finish it today. Okay, but let us now go and talk about the function whose absolute value, whose rule is the absolute value of x, the simplest absolute value function ever, okay? So what we can do, I want to talk about the absolute value function. So f of x, let me just write f of x is equal to absolute value of x. The first thing about a function, let us talk about the domain of the function. So what is the domain of this function? The domain, do you remember, is all possible values that you can choose for x and still the function is sensible. Is there any limitation here? Is there any number that I cannot choose for x? No. Because every point on the real line has a distance to the origin. So this means that the domain of this function is R. But what is the range of this function? The range means all possible outputs. So it means that you put all inputs in, hypothetically, because there are infinitely many of them, but assume that we put all the inputs in and then one by one I get some outputs. What is the range? What is the collection of those outputs? Yes?
It's greater than 0 or 0.
Or 0. So this means that the range of this function, of course, it is wrong to write this is the range because range in mathematics is a set. So if you want to write it properly, you have to write the set consisting of all, you will study set theory in Math 5 if you continue with me, but then this is good to know that this is technically wrong if you just write that. So you need to write the range of f is the set, this curly brackets means set consisting of elements in R, but with the property that x is greater than or equal to 0. And usually, because the range is the y value, even though it doesn't matter, but I prefer to clean x and write y. But of course, they are exactly the same sets, okay? Okay, so that is the first question we need to ask about a function. Okay, so what is this function if you want to understand it from diagrammatically? So what happens, you send x in, what you get out is absolute value of the number you send in. This is also operational way of thinking about the function. The second thing that we usually talk about functions is the graph of the functions, yes? So let us try to draw or sketch the graph of this function absolute value. And this is one of the famous ones, like y equals to x squared, that you have it in your memory. I recommend you to have the graph of this function in your memory, okay? So, how should I draw that? As I told you, absolute value is ubiquitous in mathematics, but whenever you want to do something with it, you have to get rid of it first. So what I do, if I want to draw the graph of this function, what should I do? I would say that, okay, I know that I have to draw 2 lines, or I have to draw 2 graphs. One graph is the graph of this, under the condition that x is non-negative, or I have to draw the graph of this under the condition that x is negative. Because when you say that I want to draw the graph of this function, you tell to yourself that if it's non-negative, there is no difference between them, so I have to draw this graph. And if x is negative, absolute value becomes negative x, so I have to draw the graph of this one. But these graphs are so famous for you, yes? Y equals to x and y equals to minus x, you can draw them. But they are not the full line anymore. Yes, for example, if I ask you to draw the graph of this one, hopefully you know this is a line. So you put x equals to 0, y becomes 0, and then you choose, for example, x equals to 1, y becomes 1, and then you go and try to draw the graph, yes? So 1 point is the origin, and 1 point is 1, 1. So this is the point. And because you know that, this is a first degree equation, so you know that the graph should be a line. So if you draw this one only, of course you connect these two and continue from both directions. So that is the graph of y equals to x. But in this case, I am interested in y equals to x only for non-negative values of x. So I have to choose that part of this which corresponds to non-negative values for x. So what does it mean? It means that this part is not acceptable. Yes? Because this part is on the left-hand side and x is negative. But I only want them for non-negative. Okay? Okay, but if I ask you just draw to this one, this is not precise. You have to make it clear for me that you have respected that this is a filled dot. Yes? Because x equals to 0 is also acceptable for this part of the graph. Okay, but what about this one? This one is y equals to minus x. I can set up another table for this one because it's a line. X and y, 0, 0. Of course, I cannot put 0 here, but I put 0, but I know that is excluded because now I am not doing this. I am just drawing the graph of that function. And then I put, for example, minus 1, y becomes 1. Again, one point is here, and the other point is here, yes? Okay, so these two should be connected, and then this, what you see is the graph for y equals to minus x. But now, in this case, I am only interested for the negative ones. So this means that x should be negative. So the positive part should be clean. And what is left is the graph of absolute value. So I will clean it and I would say y equals to absolute value of x. So here is 1, here is 1, here is minus 1. So I want you to remember the essential, this is the graph of the absolute value. So it is not a straight line. It consists of two semi-straight lines, yes? One line starts from the origin, continues forever in this direction, and one line again starts at the origin and continues for this one. And then here you don't need to fill it up, yes? Because of course it is included. Because it was included here and excluded there, so in principle that point is on the graph. So that's the graph of this function. Is that clear? Okay, that's a good idea if you also can do some of these work with this GeoGebra. Okay, so here, first of all, I think a GeoGebra, it has this symbol as well here. So if you see, you can use that. For example, let me just use that because ABS usually is the notation we use for absolute value. Okay, so here, if I want to draw the function y is equal to, so let me just use this. It's exactly like absolute value of x, and that's the graph of the function that appears here, yes? So that's exactly what I try to sketch here. This is more precise. So this is the graph of the function. Okay, so let us have a better understanding. So if you don't mind, tell me how should I solve that problem graphically now? Because solving equations graphically is actually important to understand. So as I give you that equation, I think GeoGebra is also capable of solving that analytically. We will also test that. But for the time being, let us try to solve that problem you see on the board graphically. Just tell me what I'm supposed to do. Yes?
Create a new function where it's just y equals to 3 and check where they intersect.
Between y equals to 3 and that function y. Yeah? So what Erasmus is suggesting is to draw the graph of this function, y equals to that, and draw the graph of y equals to 3, and then see where they intersect. This is one way. Another way is, which is usually better, this is working, but they usually, because softwares and applications have some kind of syntaxes that you can find the intersections with the x-axis. So it is better to solve it slightly different, yes?
Just subtract 3 from the order.
Yeah, so I move 3 to the left, and then y equals to that function, then I draw that function. Let us just do both of them. Okay, so here, if we go here, so let me get rid of this one first. So first I need to type y is equal to, so 2, so I have an absolute value open, and then I have 2, another absolute value. Oops, it doesn't work here, I don't know. So 2, let me, so I don't know why it doesn't work. So how should I do that then? Okay, let me write ABS, might be it is better. So because I want to put an absolute value inside an absolute value, it's complaint. So if I press this absolute value, it is jumping out.
You could just make sure to write something inside and then.
No, I try to put 2, okay, and then I want to put absolute value again.
Just write the equation, select it, and try it.
Okay, so it doesn't work, okay. So let me write the code, probably ABS means absolute value. And then I open a pair of brackets and then 2 times ABS. Yes, I don't know. It doesn't understand it anyway. Yeah, it understands it now. So anyway, so I need to learn that. Okay, so 2x minus 3, and then I have minus 7. So this is the graph of this function. So that is what actually, Oscar, your prediction is more or less correct. So you see that when you add absolute value signs, I have more break in the line. Okay? So here, this is the graph of that function. Okay? I did everything. Okay, and then as Rasmus first mentioned, I will draw the graph of y equals to 3. Yes? This is also the graph of that function. So it predicts how many answers we got, 4, and how many intersection points you see, exactly 4. So 1, 2, 3, and 4. But of course, if I want to solve the problem, so for example, immediately, I hope that this is clear for you, one root is minus 1. The other root seems to be between 0 and 1 exactly, and that's correct because we already solved the problem. There is a 1/2 there. But if you want to use that, you go to intersection, you find this intersect, and hopefully it works this time. So you highlight this and highlight that, and then I don't know, for some reason, it gives you only one root, but let us check this again. Yeah, so this is a little bit strange attitude, yes. So you have to do it one by one. Anyway, so we got 4, so these 4 intersection points, and now you read the coordinates. Which coordinates? The x coordinates. The x coordinates are -1, 0.5, 2.5, and 4 in exact confirmation about the numbers that I got there. Okay, so that's why I'm saying that because of these problems, it is always preferable to draw the graph of that function -3 and then look at for the intersection points on the x-axis. By the way, can you predict how the graph of that function -3 looks like?
Minus.
Yes?
It doesn't intersect with the graph.
No, I'm just talking about, so what I'm saying is that I told you that this is so I drew the graph of this part, and then I found the intersection points and then read the x coordinates. I would prefer whenever you want to solve this equation graphically, even though you can draw this and draw that separately and look at the intersection points, it is always preferable to move one of them to the other side and draw the graph of the whole thing, and instead of looking at the intersection between the graphs of functions, look at the intersection points of what you drew with the x-axis. That's my point. So here, yes, do you have questions? So yes, my question now is, what happens if I want to do it in this way? What I will do is to draw the graph of this function using GeoGebra. Yes? But before doing it with GeoGebra, I want you to predict what will happen if I draw it, yes?
The entire graph moves down, and every intersection point will be right on x, like on the x-axis, on y.
No, my question is about the red part. What happens to the graph of the function?
It will.
Can you predict what is the graph of this new function looks like?
Yeah, it will look the same, but
Move 3 units down. Yes, that is completely clear, because from whatever I had as y, I am subtracting 3. So every y goes 3 units down. So it means that the whole graph will be shifting 3 units downwards, okay? So if you don't mind, let us also do that. So let me clean all these things. And then let me just modify this. I just write -3 here, and then press enter. As you predicted correctly, so it will actually go 3 units down, okay? But it is shifted 3 units, but now you just look for the intersection with the x-axis. You don't need to draw 2 graphs, yes? And I think there are zeros here. Yeah, there are roots here. Might be this method will work better here. So I choose the roots. Hopefully it will work. Yes, it will give you all of them simultaneously. So this method was superior, yes, because you can get all of them. But then, of course, the y coordinates are all 0 because they are on the x-axis. But the x values are exactly the same numbers: -1, 1/2, 2.5, and 4, exactly the numbers. So whenever you want to solve this problem graphically, it's actually important to understand that. Okay. I think, let me just tell you something about the graphs, and then we stop here. Okay. So, can you tell me a recipe? Can you tell me a recipe about how can I draw the graph of this function? For example, I give you that this is the function. For example, let me just draw this function. By the way, can you draw this function in your head? Can you imagine what is the graph of this one? It is x squared, you know that, and then for the same reason, it is shifted 1 unit down, yes? So it is something like this. So it is 1, -1, and 1, so the graph of this one is this one. Now I'm asking you this question. Can you predict how the graph of this one looks like? Without doing it by GeoGebra. I want you to see how it works. After you understood it, we can investigate it using GeoGebra. Yes, Abdurrahman?
I believe it would be the same but shifted to the right.
Okay, so that would be the same, shifted to the right. How much?
1 increment.
What?
By 1
By 1 unit. Okay, so you say that assume that this is a rigid object. You take this rigid object and move it 1 unit to the right if I put absolute value. Okay, that's one prediction. Another one. Yes?
I think that I don't know exactly, but I know in the middle it will simply like bounce up and down again and forth. But how?
Okay, can you elaborate more? Because more or less you're right.
Between -1 and 1, it will basically create like, I don't know if it's a curve or a pyramid, but it will go up, and then at 0 it will start to go down again towards 1.
Okay, it is predictable exactly. So what you said is close to reality, but you can make it more precise. Yes, Rasmus?
Bit more precise, they would be like the bubble. Or it'll be like if we had folded up the bubble.
This is the question. So the mirror image. So because I told you, if I ask you what is absolute value of x squared minus 1, how do you understand the problem? You will tell me this is equal to absolute, this one itself, yes, if this one is positive, or it is negative of itself if x squared minus 1 is negative. Do you understand that? If I ask you what is the meaning of absolute value of x squared minus 1, you will tell me exactly the definition. You will tell me this is exactly equal to this expression if this is positive, and this is negative of this expression if this is negative. Okay? But can you see from the graph where this is positive? The graph of this function, you have it in front of you, and you want to see where this is positive. So where is it positive? On this part and on this part, yes? So this means that if these branches will not change at all, because if you are here, it means x squared minus 1 is above the x-axis, so it is positive. And if you are here, it means x squared minus 1 is above the x-axis, it is positive. And if it is positive, it doesn't change at all. Yes, is that clear or not? Okay, but this part is the part where x squared minus 1 is negative. In that case, I have to multiply every number that I get by a minus sign. So if you multiply every value that you get by a minus sign, you will actually reflect it about the x-axis. So this means that the graph of this function, with this part will not change, but this part will actually be the mirror image. I cannot draw it precisely. It should be exactly the mirror image of what you see here. Yeah, something like this. So without actually going to a lot of details, you realize that this is the graph of your function. The blue part is what I predict for this one. So as a rule of thumb, if I give you this picture, what is the graph of the absolute value of this function? So this part will remain the same because it's positive, but that part will go backwards. So the blue part will be the graph of this function. So if I go and check it, let us check it by GeoGebra. So let me get rid of these. Also this. And then I want to do that. So I would say that y is equal to absolute value x squared minus 1. Minus, so this is x squared and then minus 1. And then you see that prediction is correct. And let me also draw the y equals to x squared minus 1 itself to compare them, yes? Minus 1. And then you see that that's the same thing, yes? That's exactly what happens. But of course, I don't know why it doesn't show both. The black one should usually dominate. Okay, I can make it a little bit thicker, for example, that you can see what happens. Oops, sorry. Undo. Oh, redo. And then, for example, I can go and choose this black curve and then make it a little bit thicker so that you can still feel that, yes. Okay, that was a bad decision of mine because it's better to make this one thicker, yes. And then this one, so it doesn't show up. Line opacity.
On the left, it's below. It's like,
No, I just want to see that you can see the black one is still below the blue one.
yeah.
Might be the color is too. No.
No, it's
Okay, forget about it. Yes, because you don't need to do access. You understand that this graph is actually reflected. So the rule of thumb is this. Whenever you have the function, but an interesting question, if you are interested, you can ask yourself, if I give you the graph of this function, you'll learn how to draw the graph of this function. So by the way, that's extremely important. So if I give you the graph of a function without giving you the rule of the function and ask you what is the graph of the absolute value, you can solve. But now you can think at home, it's a harder problem. What do you think will happen to this one? If I put the absolute value inside the argument and how the graph of those are related. Okay, we will not answer this one now, but if you are interested, you can think about it. Okay, any questions? Okay, thank you. We stop here and then we continue. This is not finished. So tomorrow I will also continue with this lesson for differentiability and continuity. But still, I tell you that there is a book back there. It should be for one of you. And there is also a notebook there.